And thank you for joining us on the Session and AI Roadmap to Shared Impact. I'm going to give a bit of an unbiased opinion. I think this is going to be one of the more interesting sessions that you have taken part of in the program. One of the big topics that we have been talking about across this entire forum has been how do we coalesce all of the different efforts that we're making internationally. People are working on all kinds of different things to make agri-food systems better, to make them more inclusive, to make them more environmentally friendly and resilient. And that work is happening in different places. And we're trying to figure out how to coalesce this work. And there are certain, I would say, inflection points or key drivers of change that are happening in this space that are things that we can hop onto or grab onto, and artificial intelligence is one of them. And so what this session is really going to be about is how do we align all of the work that is happening with all of the change that we want to see happening so that we can better coalesce the work that is happening in the space of AI for agri-food systems transformation. And so there's going to be a set of use cases that you're going to hear about. We're going to hear about a roadmap to actually do this work. And I'm very happy also to see that we have a familiar set of faces, so people who have engaged with us in this space. I'm Cal Joff. I'll be helping moderate the session today. And to really to help us set the tone and the stage, it's my pleasure to invite Excellency Jezile Nosipo, who is the Ambassador and Permanent Representative of South Africa to FAO. Excellency.
Well, good morning. A fresh Thursday morning, isn't it? Thank you for this honor to be able to welcome you to this special FAO Science and Innovation Forum 2025 session. And Carl is saying this is supposed to be the exciting session, and I'm excited because I was talking to my daughter about what she thinks are the interesting things that we can anticipate with AI-driven agri-food systems. And she said, well, wouldn't it be exciting to just wake up imagining a forecast model for weather and also being able to know what you will produce with precision. So this is, in essence, what I'll talk about both as the permanent representative to the FAO. We gather today at a special moment for global agri-food systems, one marked not only by urgent challenges, but also by historic milestones. And as FAO celebrates its 80th anniversary, we welcome October 16th World Food Day, and we are reminded of our shared responsibility to advance food security and sustainable development for all. And of course, as the chairperson of the Committee on World Food Security, I also want to imagine that this is a day where we also can anticipate a day where we are going to really end hunger in the world. The challenges that face us include feeding a growing global population, strengthening our ability to be resilient to climate change, and ensuring that no one is left behind, which therefore requires bold innovation and coordination actions. Artificial intelligence, therefore, and digital technologies are rapidly transforming the landscape of agriculture and agricultural investments. And these investments or advancements are equipping us with transformative tools to boost productivity, foster inclusion, especially, again, the Committee on World Food Security is a platform of inclusion, farmers, and also even fisher folks that should at least contribute their voices in how they would also anticipate the solutions from AI in advancing their plight in agri-food systems. We hope that we are also going to be equipping ourselves to drive sustainability across agri-food systems. By harnessing innovations, the FAO and its partners are dedicated to shaping a future where agricultural development is both responsible and impactful, ensuring that, again, we develop our sector without taking away any opportunities for our future generation. Through science and innovation strategy and the digital agriculture, the AI innovation roadmap of the FAO is actively connecting the science, because agriculture is a sector of physical science and technology, and so including partnerships across other sectors which are also important, both in terms of advancing our public policies in respect of ensuring that we include society to enable young children to be at school at an age where they should be at school. And these are the technologies that will be able to enable that innovation or science innovation transformation that is anticipated by the FAO strategy. I therefore just wish to highlight a few of what is covered in the roadmap as a result of the sessions that were held during the Science and Innovation Forum in 2024. One is the Digital Agriculture Changemakers in Action and Inclusive AI to Drive Agri-Food Systems Transformation. That were then followed by the Digital Agriculture and AI Innovation Dialogue in Rome in April this year. So we therefore collectively have a shared goal that all stakeholders that were represented, that are also present here today, hope to accelerate the transformation of agri-food systems, making them more efficient, transparent, accountable, and beneficial to all of us. And I would conclude by saying that we have established a federated open framework that democratizes data and AI assets as digital public goods. Again, people think about AI in a situation where they imagine only really what they see as smart people, but also not bearing in mind that even those people that are in far-flung areas, in rural areas, where I come from in the Eastern Cape of South Africa, should be able to benefit from AI solutions. So we hope that we'll be able to foster collaboration among governments, including local government, where action takes place, researchers and innovators, through a test and learn approach. Again, we have to learn by doing, testing by doing, and also learning from the past, and continue to refine and improve the implementation plan based on those lessons that we learn. We hope also that we will move forward from problem definition to scalable deployment, preventing fragmented efforts. So all of us across the various sectors, we may have different aspects of how we innovate, but there is a point where these should connect and not disconnect. Ultimately, the aim is to deliver measurable social, economic, and environmental outcomes or benefits, which are specifically going to be of use to smallholders and the most vulnerable groups. We embark at this session today. We should remember that a true promise of AI will lie not only in technology, but it will be more on its ability to foster the trust, to build the partnerships, and ensure that innovation serves the needs of all, especially those people that I have already referred to. Working hand in hand, again, in the context of the FAO Hand in Hand program, we can close the investment gap, democratize access to data and digital tools, and scale solutions that would deliver these measurable benefits. We hope that we will have a data-driven decision-making process that is based on real insights that come from these innovations, whether it's drone innovation or satellites, which would therefore be available to all of society in order for us to advance our opportunities in agri-food systems. I invite you to therefore engage openly, share your experiences, and help shape the future where sustainable investment and responsible innovation go hand in hand. Together, therefore, we can make agri-food systems smarter, more inclusive, and more resilient for generations to come. I thank you.
Thank you so much, Excellency. And I love this call of bold innovation and bold collaboration, because I think we have some sense of what bold innovation looks like, but bold collaboration, I think we still have work to do in that space. And that's part of why we have this roadmap that we're going to be looking at in a moment. I want to get a sense, though, of who we have in the room. So who here is working on some kind of innovation that has to do with artificial intelligence and agri-food? And when I say working, it doesn't mean you have to be developing the software, right? You might be financing it, you're a product lead for it. Yeah? Okay, and of those of you who are working on one of these applications, use cases, we'll call them, how many are sort of in the development stage versus how many are already sort of in application versus how many are scaling? So development, all right, a lot of stuff at early stages, right? What's in application stage? Who's got something in application stage? Nice, and how about scaling? Ooh, interesting. This row here in the front is an interesting group. And for the rest of you who are here, what kind of, like, I saw a lot of people here who didn't put their hands up, right? What's your interest in the session? Anyone want to, let me get a mic. Let me get a mic. So for those of you who are not currently working on something, are you planning on working on something? Any hands? Yes. Let's get the mics on. Oh, it helps if you press the switch. Yes. Well, you can just tell me and I'll rebroadcast. Ah. Yeah. So potentially AI for extension farming. You're with FAO's Investment Center. Is that a hand? No? Anyone else want to tell us? Someone who's not working on a use case right now, but why you decided to join? Yep. I don't know if I'm passing you a dead mic. I'm sorry. Go ahead. Yep.
Access agriculture is about farmer videos in local languages.
Ooh.
So for extension services in Africa, it makes a lot of sense. We are talking about 80 African languages in which something like 2,000 agricultural extension videos are available. So now they have launched a chatbot whereby you can ask in Kiswahili your question and it would match you with all the databases of all the videos available, for example, on biopesticides.
That is so cool. Very cool. Okay, well, thanks for sharing. I want to invite Aymeric Thiollet, who is with the Human Technology Foundation. Aymeric, there you are. Tell us a little bit about the roadmap that's being put together. What are some of the components of it, and maybe a little bit about how we can all participate.
Yeah, sure. Thank you, Cal. So I hope everyone hears me well. So $250 billion. That was the amount that was invested by the private sector in artificial intelligence last year. That's an impressive figure, specifically given the fact that it contrasts sharply with what was dedicated to agriculture, less than 1% of this total amount. On the one hand, we can see booming AI innovation with this capital enabling great progress in AI capabilities. We can see, for example, chain of thought reasoning models. We can see vocal assistance. We also have greater AI accessibility. You can think of the open source models like Llama's, Meta, or DeepSeek. All of these advances, they actually move forward innovation. They help reduce the cost of product development, which in turn increase the rate of innovation. And I think we're going to see with my co-panelists here some examples of those innovations later on. But what we can see on the other hand is that smallholders, and specifically in low and middle income countries, have yet to see the benefits of this, right? They actually suffer through a lot of different types of crises, climate shocks, geopolitical tensions, but also unstable markets. Yet, and this is despite the fact that they produce 33% of our global food supply. So we may think sometimes that we don't have the right ideas for solutions, but actually we can see that with the many recent innovations in AI, this is not an idea problem. This is a translation problem, right? A translation problem. So why does innovation not translate into impact? What's blocking the way? Well, some of these blockers are here. So first one is fragmentation, right? We have lots of siloed efforts that do not talk to each other and that lack some interoperability. A second one is digital divide. We can see infrastructure gaps that exclude people that need solutions the most. Another one is design mismatch, those famous top-down approaches that don't match local needs. Another one is trust deficit, and this is partly due to weak governance frameworks. The feedback gap, and here we can think of governments or policymakers lacking the evidence to make the right decisions for the right people. Another one is funding opacity, investors not having the right criteria to assess projects and compare them, right? And in all of these blockers, you can see a common thread, which is the fact that those are multifaceted challenges involving very different types of stakeholders, right? And the main challenge, I would say, is an ecosystemic coordination challenge. In other words, is how do we make all those different types of stakeholders collaborate better? Well, the pathway we worked on was a 3-year AI innovation roadmap. So I guess the FAO cannot solve all of these blockers on its own. And the FAO, however, can do is create the right conditions for those different types of actors to collaborate. And this is what happened last May. So my name is Emeric, and I'm working with the Human Technology Foundation, a think tank on the ethics of technology. And I had the chance to contribute to the organization of this first Digital Agriculture and AI Innovation Dialogue last May, which convened 90 experts from a very broad, vast range of stakeholders. So from academia, from the private sector, from policymakers, governments. And all of these experts got together with the goal of solving one big question, is how do we coordinate our actions better when it comes to AI innovation, right? And a lot of different initiatives emerged from these interesting workshops and discussions. I'll focus on 2 main ones today. The first one is mission, 5 big common focus areas where AI drives impact, and services, a first set of shared tools to design, test, and scale AI solutions. So let me start with the missions. So when the experts got together, we had lots of ideas for solutions, lots of problems. The goal was to kind of focus them on 5 big ones. And through these missions, you can map use cases, and we have a lot of solutions that came up. The first one was closing the field intelligence gap. Is how do we get the agricultural information and insights from research, for example, to the local needs of the farmers? And from the farmers, how do we get their feedback back to decision makers? The second one was unlocking fair and efficient market access. Here, it's especially to help local farmers and smallholders to have fairer prices for their products and more transparent market conditions. A third one was building risk-ready agri-food systems. Here, it's to help those farmers resist the different types of shock they go through, disease outbreaks, climate crisis. A fourth one was upgrading institutional capacity. How do we help governments make the right use of their data to make the right decisions for the right people? And the last one was optimizing farming through analytics. We have lots of very interesting agricultural data, but how do we get them into the hands of farmers for them to grow more without spending less resources, right, to be more efficient? All of these missions can kind of constitute a canvas, a common frame where a lot of use cases have emerged and AI solutions. And this can help you as a frame to put your solutions and use cases. Then we worked on services. And here, this is a shared of tools that was meant to help design, test, and scale AI solutions. So you have the Science, Technology and Innovation Portal and Network that was created, and I think it will be there will be a demo in the acceleration zone right after this session. So if you want to find out what it is, but it's basically an LLM-assisted platform in order to connect innovators with expertise. And this works in cycle, right? Because when you discover and connect with ideas, you can then prototype and test them. And this is the purpose of the AI Sandbox, which is an experimental tool that is developed to help innovators access the right data sets in order to develop their products. A third one is innovation hubs. Those are regional nodes to truly match the solutions with local needs. And this is currently developed right now as well. And overall, all of this, we also worked on an AI governance toolkit. This is through each stage of the innovation cycle, and the FAO is currently working on an innovation methodology framework in order to really streamline all of these tools together. We can think of specific questions that can help truly make AI projects impactful. And I'll focus a little bit on this toolkit right now. So this toolkit is made up of assessment criteria that will help launch, pilot, and scale those impactful solutions. Here, what was interesting was to put together in the same room funders, innovators, policymakers, in order to think of what could be a common set of criteria, of questions that will help us be on the same page when it comes to AI projects and AI use cases. And here you have some of them. It's actually 7 criteria, must-haves and could-haves. They were separated this way because what we got is that in every context, you must consider some criteria. But in others, for example, you cannot always make solutions open source, but it's better to try. So those were could-haves, right? Differentiating those different types of criteria in order to help, for example, funders compare those different types of projects with those assessment questions. So I guess by now you probably got the gist of it. In order to bridge the AI innovation to agricultural impact gap, we need better ecosystemic coordination. And this is where you come in. You can join this community and the STI network that is being built up right now. You can join us at the next Digital Agriculture and AI Innovation Dialogue. You can contribute your AI agri-food project or solution, develop in the AI Sandbox, or invest in proven solutions. And I think we'll see about them right now. Thanks.
Fantastic. Thanks so much, Aymeric. And Aymeric, if I can just invite you, join us on the panel. I want to ask you a follow-up, and let me pass you a mic for this. So just to make sure I understand this correctly, right? The top line goal is how do we all work together towards inclusive, sustainable agri-food systems? And then in this AI dialogue, different stakeholders from the technology space, from the private sector, public sector, civil society came together to identify 5 key missions that are believed to be some of the most important things that we need to do to get there. And then underneath that, you've got essentially the diagram that you showed us, that flow diagram, right? So you've got a platform, you've got a tool that helps connect people, and then you've got these hubs that can help you connect into countries to, I suppose, test out and sort of experiment with some of these solutions. Am I understanding that correctly?
Yeah, absolutely. Yeah.
Okay.
So yes, that's it. The goal was to have really a common focus areas, because the tough problem is to really focus the effort somewhere, because you have lots of solutions that exist, but sometimes, and it's maybe it's crazy to say it, but they don't solve actual problems, right? Or they don't solve important problems, problems that can be replicated in other places. That really matters, right? This was the purpose of the missions, and these missions actually provide the frame of reference for AI use cases and then products that can be mapped onto those missions, right?
Got it.
And all of the services that I talked about, they can help advance, I would say, those use cases towards the mission.
Yeah. And so speaking of those use cases, I want to invite Gabriel Tsengs, who is a scientist with AI2, an institute, as well as NASA, to talk a little bit about what AI can do across the missions, and specifically around some really interesting work that he has been doing with geospatial. Gabriel.
Cool. Hello, I'm Gabby. So Aymeric gave you the very high picture. I'm going to... interesting. Do I keep clicking more? Ricardo?
Maybe just while we wait for the slides to come up, tell us a little bit about your work.
Okay, cool. I'm Gabby. So Emmerich give you a very high level. I'm going to zoom right in. Yeah, I'm a research scientist at AI2. So AI2, the Allen Institute for Artificial Intelligence, is a research nonprofit. We build lots of different things, including language models and vision research, but we also do research into applications to satellite data. And that's my specialty. That's what I'll talk about today. And I'll talk about specifically some applications to agriculture. Cool. So satellites and machine learning can help us understand agriculture at scale. For instance, you might want to know where maize is growing, and you might want to know where maize is growing everywhere around the planet. And this is exactly something that actually folks have already asked. This is a map produced by World Cereal, an ESA-funded effort mapping maize globally. And if you poke underneath the hood of World Cereal, what you see is exactly what I just described. So on the left, you have a bunch of different satellite inputs. That's what those cubes represent. We have directly observed variables, things like Sentinel-2 optical data or Sentinel-1 SAR data, but also derived products, so weather data, elevation maps, this kind of thing. It all gets piped into a machine learning model, in this case, a model called Presto, and then that model gives you predictions of where maize is in order to make this map. So I was told to a bit show you what was possible, a bit what we were researching, so this is what I'm going to do in the next bit. So Presto is a foundation model that we developed for satellite data. In this case, we is NASA Harvest. What are foundation models for satellite data? It's a relatively recent term, and it's especially recent in the context of satellite. We here again being Harvest, first encountered this when we were trying to make agricultural maps quickly with very few labels. So in particular, during the COVID pandemic, the Togolese government asked us to make a cropland map for them so they could get an estimate for how their farmers were spatially distributed around the country. We had 10 days to do this, and I think at the time there were like 50 crop, non-crop labels distributed around the entire country. So how do we do this? Because we did end up making a map for the Togolese government. The first was that we leveraged lots of different sensors. So that's kind of like the photo I showed you before, using as many different satellite sensors as are available, but also derived products. And the second is to use a machine learning model which already knows lots about the planet. And the idea here is that it already knows the relationships between these sensors and lots of things that we might care about. And that way, even if you do have very few labels, it can make a map that you want as well. So if my model already knows what the relations between these sensors and agriculture is, it can relatively easily make me a crop or non-crop map. So how do we get these foundation models? Well, first we design a training algorithm which learns about the world from many different sensors. Here we have ESA Sentinels, but lots of different things. As I mentioned, these derived products are really important as well, weather, topography, and also outputs of other machine learning models, land cover maps, this kind of thing. And then we train the model on data from the entire planet. Again, so that anywhere that we might want to apply this model, because we won't know beforehand where that will be, the model has already seen it and can hopefully make high-quality maps. Yes, and so obviously at Harvest we were interested in this because we needed to make a map in Togo quickly, but actually World Cereal is a multi-year effort. They have way more than 50 labels. They have thousands and thousands of labels. Why do they care about this too? Well, as you can see, World Cereal is in the business of making global maps, but we do not have global labels. So here our labels are quite spatially imbalanced. So even though we don't have any labels, for instance, in Australia, we still want to make a map in Australia that's relatively accurate. And so this is kind of the spatial generalization that we were targeting when we worked alongside World Cereal. Yes, and I think an interesting thing to note here is that we are deploying these models at scale. They're kind of going from research into the application, this gap that you were talking about, Carl. So if you go onto the World Cereal website and make your own custom crop type map, this is something that they support in any region of the world. Under the hood, you have a Presto model. And we did quite extensive testing alongside the World Cereal team. This was work led by Christina, to make sure that we were delivering on these promises. So here, across different train test splits, basically different ways of holding out data from the training set, we do perform much better than the deployed baseline, which was the phase 1 World Cereal project, expert features into a machine learning classifier. Okay, so this was one example, which was cropland mapping. I spent quite a bit of time on that because I suspect, as many of you know, cropland mapping is the foundation for so many other things that we need to know about the agri-food system. But I'll give you a different example just to show that these models are relatively versatile and they can do many different things. So you might ask, where is maize growing everywhere on the planet? You might also ask, what is the risk of fire in the Rio Grande National Forest in Colorado? So currently, the way that one of the ways that foresters estimate fuel risk is by using this metric called live fuel moisture content. Basically, what you do is you go into a forest, you gather some vegetation, you weigh it, you dry it out in an oven, and then you weigh it again. And the ratio of those two weights gives you this metric, LFMC. Basically, it's telling you how moist the vegetation is and therefore how flammable it is. This requires going into the forest, getting a sample, and taking that sample back to the lab. It is very, very difficult, especially in hard-to-access areas. So to make this concrete, in the Rio Grande, they had one sampling site over here. They've collected 50 samples since 2017. This is not ideal because LFMC is very spatially variable. One of the ways that foresters might use it is during an active fire event to kind of understand how the fire is going to evolve. And so if the only place that you know where the LFMC is at this red star, yeah, you're really not going to have a good idea of how the fire is going to evolve or of the risk of fire throughout your entire forest. So luckily, there have been lots of LFMC sampling efforts. Here we were using Marta Yebra's Globe LFMC 2.0 data set. But as you can see, this is kind of a similar setup to the world cereal problem, where we have lots of data in some places, but also major gaps in others, especially where we might want to make a map. Yeah, and so again, using one of these foundation models, in this case, a follow-up from Presto called Galileo that we developed over at AI2, we were able to make these spatially complete and also temporally complete maps of LFMC in the Rio Grande. And obviously, it's hard to validate maps if you only have 50 labels in one single point, and so this required working closely with foresters to basically sanity check, make sure that this matched their intuitions of what LFMC looked like over time and over space. So yeah, if you were interested in learning more, we're kind of heads down building this, but hopefully very soon we'll have things to show over at the Earth System URL here. Thank you. Okay.
And then, so thank you so much. And then finally, I'd like to invite Brenda Mulele-Gunde, who is the global lead in ICT4D with IFAD, to talk a little bit about the enabling environment. So Aymeric has talked about the sort of framework that can help bring us together for collaboration. Gabby has talked about what are some specific applications and what they can look like. Brenda's going to talk a little bit about the governance side of things. So Brenda.
Yeah, thank you so much, and good morning. Good morning.
Good morning.
That's better, you're there. All right, so I'm going to talk about the enabling environment. I think as the other presentations have been talking about, they have defined the roadmap. This is where we have to go. And then we have a use case of saying, this is actually the way we can actually do it, but we're asking, is it possible? What are some of the things that we need in a particular context? It could be in a country, it could be regionally, for us to be able to achieve AI for transformation. So before I talk about that, I just want to elaborate a little bit. I work for IFAD, which is the International Fund for Agricultural Development, part of the United Nations. We are working also on supporting rural transformation. Our vision, mostly for digital, is that it is a catalyst for rural transformation. So our role is to provide trusted advisory, looking at investments, but also looking at convening inclusive digital AI. We're also looking at a current vision that says we need to refocus a little bit in terms of what are the key things that we need for us to be able to achieve rural transformation. So the pillars on digital public infrastructures, I'll talk about more about that. AI that is more inclusive, but also that our services are more farmer-centered. And our mandate is more human-centered, not the technology. So there's a hype around AI, but our ultimate goal is to ensure that we are actually supporting to address the challenges that smallholder farmers are facing. Now, to build that, we need to focus on specific things that are enabling the environment to us to deliver AI for rural transformation. 4 things that I'm going to talk about. One is the infrastructure. Yes, we might talk about models, we'll talk about everything else, but where there's no connectivity, a farmer may not be able to access all the services. Basic infrastructure is needed for us to be able to deliver AI for transformation. We need the right institutions that are coming together, developing policies, and we need the right people and the business ecosystem. So I'll go about these blocks one by one. The first one is about the infrastructure. For us to be able to deliver, like I said, we need better data, better models that will result to better services. The first one is we have been hearing a lot about digital public infrastructure. Why is it there? Why is it needed after all? If we already have artificial intelligence, why do we need to focus our services on foundational services? Digital public infrastructures enable us to get the best data that is available for us to be able to build the rails towards AI as a use case. AI is a use case, it's not the end on itself. It needs data for it to be able to deliver the services for smallholder farmers. And that's what digital public infrastructure helps us, whether it's coming from data that is coming from farmer registries, knowing who the farmer is, what they are, where are they, what are they producing. So all these questions that the data is collecting through this farmer registry is what is going to enable better models for AI. IDs and name of the farmer, where are they? What is the national ID? What are they connected? In what geographical area are they? Answering all those questions. Payments, what is their credit score? Who are they working with? Which financial institutions are they working with? So all those questions is data that is being developed. And then we're talking about first mile coverage. Most of the times we're talking about last mile coverage. And somebody said, why are we talking about the last mile? That's not the last mile. It's actually the first mile because that's where the data is coming from. So farmers are not where the data is coming. It's not the first, it's not the last mile. It's actually where that data, the source of the data. So we need to look at that. And then we are talking about shared community access. Because the data itself, when you're looking at farmers, they're not working as individuals. Yes, they have individual farms, but they're also working in cooperatives. They're working in farm organizations. They're working as part of a group. So we need to start also focusing our attention on that data that is coming from those cooperatives, from the farmer groups, farmer field schools, etc. And then we've got offline capabilities. As much as we're talking about AI and everything, still for the smallholder farmer, they're working in the remotest area. Can we be able to transform our artificial intelligence to be able to deliver all this data, but also in an offline mode? So those are some of the questions that we are asking. And then we're looking at pumping systems. The pumping system is not the water systems, but it's more the data pumping systems. Interoperability. Are the systems speaking to one another? You have Ministry of ICT, you've got Ministry of Agriculture, you have Ministry of Livestock in a country, you've got Ministry of Statistics. Are these systems speaking to one another? Are they interoperable? Then you have got all the systems that we're developing. FAO is developing a system. IFAD is developing a system. Gates is developing a system. We have, are they speaking to one another? Can they be able to talk to one another? Can we be able to share data? So those are the questions that we're asking. Can we be able to say we have better data, that we can develop better models and better services? The second block is about institutions and policy. When you talk about institutions and governance, it's not just about that we want to govern data. Because the moment we hear governance, it's more about, no, we need to put rules and restrictions and policies and procedures. It's more about how do we create a trusted environment whereby our national AI frameworks are anchored towards, yes, data protection, but they're also promoting data transparency. The second one is about ownership. If we look at farmer registry, for example, most of them, they're owned by, if they're public, they're owned by government. If they're private, is proprietary data, meaning that that data is sitting with a particular agri-tech who cannot share with others because they also say, I put money to collect this data, right? So how do we create a ownership that is actually co-owned, data that is co-owned? You can actually say a public institution is responsible for creating the farmer registry, but anything else that is collected alongside is actually crowdsourced data. When it's crowdsourced, that means you're creating now a co-ownership. And the question that you're asking here about, can we be able to work together? Those are the questions that we can be able to ask. Incentives. What incentives are we creating for agri-techs for them to work with smallholder farmers? Right now, most of the questions that private sector says is, it is very expensive for us to work with smallholder farmers because, one, data collection, customer acquisition, all these things are very expensive for us. So how do we ensure that we are putting up the rails in these institutions and policies to enable that we are removing the cost of acquisition? And that's the role of government, to ensure that the data that is available, the foundation first mile data, is actually de-risking for agri-techs and fintechs for them to work with smallholder farmers. And then there's policy coherence, ensuring that the digital and financial sectors have the convening power and the coalition of government, bringing in the farmer voice and private sector for a common goal. And then we have the human-centric. When all this is said and done, we need to ensure that the people that are working, the policymakers, can be able to utilize our services. We can be talking about science, innovation, and the best models out there, but when we don't have the right capacity to understand the data, to utilize the data, to transform it into meaningful services, then it becomes a challenge. We need also to ensure that we are safeguarding, do no harm. Because if you're looking at the data that's been collected on farmers, there's a farmer benefit. So we collect all this data about the farmer. Do they benefit from it? Who benefits from it? So these questions is the one that we're asking critically and say, yes, we can develop an AI model that provides extension services, that provides access to markets, is providing prediction data, but at the end of the day, we also need to ensure that the farmer benefits, because he is the one who's providing the foundational data, yet the benefit goes to somebody else who's making a profit out of that data. Last one is on digital literacy and skills. It is very important that we need to ensure that the adoption, especially for women and youth, is available. Now we have the last block, which is on partnership, the ecosystem itself, ensuring that our financing models that are supporting the agri-techs, we have the investment models, and also some of the teams are bringing in the technical assistance, the expertise for them to have great incentives for inclusive climate smart innovations. We also need to look at coalitions. I think we've talked about that, the partnerships of bringing together people, stakeholders, to develop these multi-stakeholder platforms that foster trust and interoperability. So the question that I want to ask, I think I was being asked to talk about governance, can we really govern AI? I think the answer is yes. Don't look at it in a negative way. We can govern the way we utilize AI. It means that we need to ensure that we are all understanding that AI is advancing more than we can actually manage it. When we come today, I'll give a short example quickly. There was this thing going on online about a man behind a gate. I was like, so my daughter comes in and shows me a man on our gate at night. She took a picture of it, and then there was a man, and it was so real. She said, there's a man at our gate. I freaked out. I took my phone trying to call. I'm saying, I'm calling. I say, who are you calling? I said, no, I have to call. Do I call the landlord? Do I call the police? There's a man really at the gate, and he was standing there, and she laughed. She says, no, this is just a prank. I look at it, I'm telling you, maybe it's my old age, but it was real. It was real. But what is that telling us? That AI is evolving quickly than we can even adopt it, especially when looking at the agriculture sector. So what does it really mean for us? We need to look at how it's not about controlling the algorithms. We need to let innovation flourish, but we need to understand how is it evolving? How is it enabling that we are also understanding how this AI is behaving to the way that when it impacts food systems, we can actually adopt it better. Who is it serving? I'm still asking, who is benefiting from this? The other part is true AI governance is not about taming the intelligence, right? When we talk about governance, we always think, let's tame it, let's make prices. No, it's about designing integrity into the systems. When you collect farmer data, when you develop the systems, there is transparency in terms of how that data is going to be used and how it's going to support. Lastly, is that the solution itself, the end goal is that it is going to really drive transformation, where it is inclusive and that farmers are real connected. So when we go back to the roadmap, the first one, which is about equitable access, the governance frameworks need to ensure that farmers can access data, can access markets, we have the right policies, we have the right standards, we have institutional capacity to help governments to understand this data and manage it. The other part also is that we are ensuring that AI is informing us, it's not replacing human judgment. We are not robots. We are not being taken over by AI. We still have to use our judgment to understand the algorithm, to understand what is the implication. So ensure that the governance itself is actually helping us to be more responsible and more actors that are coming in as well as we do this risk mapping and modeling. Ensuring that there's transparency. I think there's an example of an agri-LLM that is being developed. The pilot, can we be transparent about how it's going to be used? And there's also policy coherence, embedding AI into national plans and strategies so that these roadmaps can be transformed into long-term strategies for the governments and the ministries that we work with. Thank you so much.
Thank you so much, Brenda. So I'm going to come back to all three of you in a little bit, but I want to move into some presentations about particular use cases, right? So we've heard about the enabling environment. We've heard about the possibilities around geospatial, the roadmap that Emeric presented, and now what we're starting to see are what are some of the different possible use cases that hopefully could be accelerated by us working together, by us putting in place the right kind of enabling environment. And our first sharing is going to come from Prateep Basu, who's joining us online. And Prateep is an irrigation optimizer, is going to be sharing on irrigation optimization and yield forecasting. So Prateep, thank you so much for joining us online, and over to you.
Thank you so much. I hope I'm audible properly.
We can hear you.
Oh, you can hear her or can't?
I can hear. Yes, we can hear you. Yeah, we can. It is possible for us to hear you.
Awesome. Thank you. So I share my screen quickly. Thank you so much for the opportunity to be presenting about our work. So I'll quickly begin by highlighting how both the topics of irrigation and yield optimization actually goes and sits into solving certain specific problems, as mentioned earlier by our moderator in the session. At SatSure, we are actually combining these two along with a few others in enabling credit for smallholder farmers who do not have access to institutional credit due to lack of the perception of risk that banks are unable to make on them. Now, in this particular slide, I wanted to highlight from an Indian perspective, where we have about 120 million plus farmers who are engaged in the agriculture activity, and about 85% of them are small landholders, which is less than a hectare of landholding. Now, when financial institutions who are supposed to be lending to them, and these are institutional banks, large banks. In India, there is a mandate to lend in rural sector. It's called priority sector lending, but yet the banks have been unable to provide access to more than 40% of the total agriculture population here. And for them, the challenges are multiple. One is obviously they do not have key data on land ownership, what crop they are growing, what production they have, whether they have irrigation facility, how the irrigation impact on yield is happening. So these are very critical factors when it comes to understanding the productivity of the land. Second comes the impact of climate risk, which is directly linked to the repayment behavior prediction of a farmer. So this is where the power of Earth observation satellites and AI comes together. Now, AI is not force-fitted here. I'll explain why. Because while we have tremendous amount of satellite data today available to analyze our planet, when it comes to analyzing less than a hectare, the predictability of it and the trust on the inferred data can be low, and it is scientific. It is scientifically proven, which is where the entire aspect of doing what we call a ground truthing comes. It's a linear process. We saw a problem that is a big problem. We saw that if we go with traditional machine learning approach, we'll brittle train the algorithm to detect the crops, and hence we kept on building the training data, which was not available as a digital public good in India. And today we are at a point where we have transformed what used to be taking 15 to 30 days for a bank to assess whether a farmer is credit worthy and the loan should be given. That 15 to 30 day process is today less than a day. in some places it's even like 10 minutes. And this entire transition from a paper-based loan processes to completely digital loan processes is one of the biggest impact that we have had at SatSure, where the entire dependency on manual checks, field verification of facilities on irrigation, the estimation of yield, it was left to individual farmers providing that information, as well as banks assessing it based on their understanding. Now, while I have given directly the high level impact and the need for it, what is important for everyone to also understand is that satellite images that we get from Copernicus, for example, these are all information that are continuous in space and time, and this is the precise the crop chronology estimation approach that we took, where each and every growth phase of the crops were mapped and we did the feature buildings around it, so that we could arrive at predicted information on irrigation patterns, on land use productivity, etc. So the one thing that was a challenge for us was that what is the statistically significant amount of ground truth and labels to collect, and we did that, I would say, made a lot of mistakes initially, but today where we are, which I'll show as a digital journey quickly, is that a credit manager can digitally log into our portal. Sometimes it's their internal loan management system and we have an API integrated. But for the purpose of the audience, I'll just show how this journey digitally looks like for folks. So I'm just selecting the survey numbers here. Survey numbers is nothing but the land associated identification number. So in India, the land digitization was the first thing which I would say was a critical path for us actually creating this solution, because our solution is based on satellite remote sensing and AI. But without the land info, but where the parcel is, like what I'm going to show you, immediately it based on the information, it takes you to a particular parcel. As you can see, it's a very small area of land, and a credit manager can assign a certain report, like loan identification number, and in a matter of a few seconds, just like a typical credit score that people like us get, this will generate a farm report. Now, in the interest of time, I'll just see for a few seconds if the report has been generated. I had some issues with the internet earlier. Otherwise, I'll download one of the existing reports. So essentially, the report would have something of a scoring mechanism, which is directly linked to the crop productivity as a proxy for income. And it would be essentially the sensitivity of it will be driven by factors like how many times the farmer is doing the cropping, what is the irrigation availability, what is the drought risk, flood risk, all of it. So I should just download one of these reports and show you.
And Prateep, so who would be using this? Would this be like a bank, a loan approver, a bank manager? Who's the user here?
The user here would be the credit manager who is associated with a particular bank, and this particular persona, they would be working on a business rule that is set by the head of risk of the bank. I hope that answers your question. So I'll just go to the presentation now that you have seen the journey here, where this in particular report provides information of the last 3 to 5 years of cropping patterns, productivity patterns, information on the climate risk parameters, and all of that is finally going into one single score. This particular score is where the banks, we worked with them collaboratively and then identified at what binning values of the score is the potential loss for them. So in the absence of credit score, we introduce this alternate credit score, and today we are processing data or crunching data for 100 million hectares on a monthly basis, which addresses today more than 2.5 million farmers who have accessed credit through the banks who use our reports. And we have done or we have supported independent studies. This is one conducted by University of Washington, St. Louis, where they saw that out of randomly selected some 50,000 plots out of the 2.5 million that have been pulled by banks in the last 2 years, about a very big portion of that 50,000 randomly selected plot people were new to credit farmers. Like they have never been part of the institutional credit system. And there is a stark improvement in the productivity of the land post the credit disbursement. Like prior to them getting the credit and after them getting credit, because in the event of them getting the credit required us to identify where is their land. So we could go back in history, which is thanks again to satellite remote sensing archives. We could also continuously track these plots and see this change in productivity happening. Why? Because the usage of funds that are being disbursed through this particular alternate credit scoring goes into investment into the farm. And that is the power of data, and that is the power of AI if used properly. Now, obviously, there are checks and balances that we put in terms of the trustworthiness of the data, in terms of the physical checks also that are required along with this. But what it has enabled is a high velocity credit penetration by institutional banks in India, which is where also certain banks ended up investing in our company because we are actually serving a national mandate. So thank you again for this opportunity to show the case study from India of how AI and satellite remote sensing has been actually deployed on ground.
This is fantastic. Thanks so much. And so it looks like what you've shared with us is a solution that is unlocking, has the potential to unlock a great deal of credit that is already used on millions of farms. And, you know, one of the things that's kind of interesting to me is also the shift, because we usually talk about people having a credit score. Essentially, you're giving a credit score to a piece of land, right? And it's an interesting shift in this work. So thank you very much, Pradeep, for sharing. We're going to move to our next use case in this space, which will be with Ricardo Soldan, who is working on AI for compliance and data democratization. Ricardo.
Thanks, Carl. Yes, hi everyone. I'm in FAO, and today I will show you about two use cases of AI application directly linked to the risk in investment. One is from our own team, so part of the Safeguard team, and one I have the honor to present on behalf of Carl Mortel, who is sitting here, who is the team lead of agroinformatics. So we'll show you two examples really of FAO-driven work. So let's start from the first use case, which is what we are developing. And let's start firstly from understanding what are safeguards, since I'm part of the Safeguard team. So in principle, safeguards are there to ensure that you maximize positive impacts from implementation of project on the ground. Now, the way in which safeguards are operationalized is through the first step, which we call basically risk screening. And what risk screening is about is trying to identify unintentional risks that could arise from implementing in a certain place a certain activity based on the context, what we call baseline information, which what you would see there, the little man with all of that data around him is basically context. Now, why screening is important is because it drives the specific safeguards instrument that you apply downstream, based on the risk that you identified and based on the level of risk. So despite being very important, a step is often overlooked, is where people spend the least amount of time doing. So this is a little bit where we are kind of, this landscape in which we are developing a solution for. Now, some people may say we don't have data. Actually, I would say today we have huge amount of data. And when I talk about data, it's not just structured data, it's also unstructured data, what it means text, right? We have tabular data, we have geospatial data, but we also have a lot of text, right? Now, what AI can really help us do is connecting all of these informations to basically reveal, see hidden connections behind this data. What is the main pattern? For instance, you can look at land use changes, but are you able to identify why this is happening? Maybe it could be a policy shift. And so this is the way in which we are thinking of application of AI, is to connect information to help us revealing hidden patterns. How is that is possible? What we are developing is a multi-step, semi-autonomous agentic system that basically start with the deterministic input data. This is the sort of information that allow us to establish a reliable baseline for agriculture. And this is also expert-driven. So what do we need to have context, which is agriculture-related? Then this information is organized and stored into a memory layer, which is a little bit kind of an advanced knowledge base that AI can use to identify risks. This I'm talking about environmental and social risks based on the project location and activity. So let's do a quick example here, in which, for example, let's say you are planning to working on a project in Kenya. You don't know exactly where, but you can already start talking about what your project will be doing. And this is all that is needed to trigger a background process that will lead to AI-generated content that the user is prompted to edit, review, or accept. So this is our human in the loop. And so only after accepting the content, the user receives a PDF report, which is the AI content, which contains all of the data and the interpretation of the data. In the last chapter, we have the first a glimpse of what has to come, which is a risk report. Using AI to identify those risks on the locational activities. Now, all of these interpretations, AI brings together data, but also peer review literature and country reports to give you a coherent narrative across different streams of information. So this is all, for example, all of the geospatial and temporal data that AI has seen, and which is embedded in the report as figures, but also AI was used actual raw data behind it. Now, I'm just scrolling down through the report, which is keep in development, but is already about 70 pages long, so it's very comprehensive. And in the last chapter, what I was mentioning before, is here the first part of the first attempt where we are talking about risk identifications, even localized as specific counties. Now, this report has already been, the AI had already been basically seeing 85 peer review literature, more than hundreds country-level reports, and tens of gigabytes of data. So now next, this is the work of the agri-informatic teams. And so what I'm going to talk to you about is the agri-informatic platforms, which is basically a unified data and intelligent infrastructure system that allows to organize multiple data sources into a coherent data catalog. And the way which is then made into an actionable knowledge for many applications, going from early warning to informed decision making, etc. Now, the way in which that is possible is operationalized through mainly 4 pillars. So access, so people can access an harmonized data catalog just to look at the data. And that is possible because there are 2 important pillars, which are harmonization and documentation. So the data that is hosted in the platform has been harmonized because it has from diverse sources, not just geospatial data and remote sensing, but is also socio and environmental data sets. And is all documented, so it's a rich metadata. You can go down to the exact source, but also to the specific caveat on the licenses, etc. And unite because, again, is united across many and several domains. It's not just climate, it's a diverse range of data set. Now, the way in which that is made actionable is through, let's call them services or tools, depending on the level of what is needed and the expertise of the users. The users can just visualize the data, they can access the data, but they can also start doing advanced processing, like, for example, requesting zona statistics, on doing computation on the cloud, or even data management workflows. Now, this is where AI comes in, and this is ongoing work from Carl's team. But in principle, they are developing this called AIDA, Agri-Informatics Digital Assistant. And what this is you can imagine as a bit of a chatbot, but behind is a multi-agentic system that basically understands the user request, knows where to find the data from the agri-informatic platforms, it knows how to get that data, it knows how to interpret the data and give it back to the user. Now, Here you see a little bit of an example in which a user is requesting what is the agricultural water demand in Kenya in the last 10 years. So in this case, the agentic system understands that the data can be fetched from Aquastat, and it the data which can be downloaded from the user, but also gives you charts and interpretations. Then this tool, this agentic framework system, can be applied to other tools. Now, this is an example of the DSP, it's the Digital Services Portfolio, which is basically a cloud platform that contains data for 10 countries that has been provided by national stakeholders. And so this is data helpful for actual farmers provided by national people on the ground in those countries. And the way in which AIDA operates is by using that information to make it delivered to farmers through a mobile app. And it can be also translated into local languages. So a farmer can use a mobile app. Based on the location of the farmer, the chatbot would understand what data is needed based on the context. And then, for example, in this case, a user was asking about what could be diseases that would affect my aquaculture activities. And then AIDA directly retrieves the relevant data, which is provided by the country and the national stakeholders, interprets that and give it back to the user really at a single individual farmer level through a mobile app. So what else is coming next now, and this is a bit of the synergy between the two teams, is the system that we are building, which tries to make sense of multiple sources of information using AI, is going to be basically moving into using the data which is hosted in the agroinformatic platforms, trying to make sense of all of these different data sets all together, basically, to drive, in our case, risk screening. And so in this way, we're kind of shifting the mentality from something that always been considered compliance to more like creating more robust sort of project design since the beginning.
Yeah.
Yeah, that's it.
Okay, excellent. Thank you. So it sounds like our first presentation with Prateep was on de-risking finance, and Ricardo, I think what you're sharing with us is there are a lot of people who talk about the reinvention, how AI is going to force a reinvention of knowledge management. You're illustrating what that looks like, firstly, right? Because the approaches to managing all of this information, data, knowledge out there is very different, right? In the tools that you're sharing. But it's also an input into design, right? And so we're actually potentially significantly changing how we design the use cases, the interventions that fall under this roadmap eventually. Yeah, excellent. So I want to move to our last sharing, which will be with Professor Salah Shukaria, who is going to be sharing on something very different, actually, on robotics and digital farmhands. So we're now going to go much more into the physical world. Professor.
Thank you. Good morning, everyone, and truly is an honour to be here today. So hopefully I'll get to talk to you about some of the work that we've been doing in our lab. From an engineering background, and I use AI, so that's why this is going to be termed physical AI. So what does it mean to take machinery and embody it with some sort of level of AI, and can we do it in some way that helps smallholder farmers and work with that? We have two major themes within our group. There's about 40 engineers in the lab. Focusing on ag robotics. About a third of those engineers work in smallholder farmers. But fundamentally what we're trying to do is ask ourselves, if we put AI in machines, what happens then? How do those machines become smarter? Can we do precision agriculture? Can we do it in some way that helps smallholder farmers? Now that you have these AI-enabled machines, how can you help farmers and support them with precision and efficiency, but more importantly, inclusion as well? If these systems become easier to use, do we have a wider cohort of people that can use them on smallholder farms? And then finally, when you close the loop, you have now people and AI and machines, and there's this sharing of information and data. How does that field level data move up into higher level intelligence, AI systems, etc.? And likewise, how does that global information feed down to the local plot and where the machine can be used? I'm just going to give you an example of what is done. This is a very simple platform, 2 wheels inside, There's power, there's computing, there's sensing as well. Very easy to put together in the space of about 10 minutes. It's easy to dismantle as well, and basically what it is a drone but on wheels. And what the benefit is, with the amount of batteries that you have, you can go for about 4 to 6 hours on a paddock, which gives you a lot longer life. You can carry things, you can move things around, etc. It looks very simple, but that's the objective. How do you make something as simple as possible that you can take it from one location to another? So that's one part of the whole process. And the other part of the whole process is how can we use sensing in some way to make that type of platform more intelligent? Your phone is probably the best example of a high-powered computing platform with a very good sensor on board. You can hack into these phones quite easily, put some open source machine learning software on board, and then all of a sudden you have a tool that can do crop disease, can monitor pests, can even look at crop yield estimation very easily. The reason why we focus on smartphones as a technique for these smallholder farmers is they're ubiquitous. You can buy a smartphone anywhere. A selfie stick is a nice gimbaled platform. If you ever want to keep a sensor facing directly onto a plant, for $30, you can buy yourself a selfie stick, you can put it onto the platform, and then all of a sudden you have this controlled sensor platform that you can mount onto the platform that I showed you before. And as you can see on the image on the right, you can start doing crop yield estimation very, very easily. We did this particular test, for example, in Indonesia. This was one of the trials that we had that was funded by the Australian government, just to demonstrate that we could go from one farm to another farm quite easily by putting this platform onto the back of a vehicle, mounting it, testing it out, putting the sensor on there, putting the camera system on board as well, and then all of a sudden you have this platform that can move up and down rows, and you can start to collect information, use that information to support the farmers in different ways. This project was also demonstrated in Fiji and Samoa, and we had a number of different projects in the South Pacific to focus on looking at how this technology may work. One of the biggest issues that we want to face is, or that we have to try and understand, is how does the surrounding ecosystem help us in terms of being able to build these platforms, which I'll talk about next. If you take that type of platform, you have this smartphone that can do things such as crop yield and disease detection and plant health, for example. You can also now start to add tools onto that platform, and those platforms can be controlled by that smartphone as well to be able to do things such as precision tasking. So we're doing very much what you would normally see in a large tractor, but how do we build it in a very modular manner? How do we use techniques such as 3D printing, off-the-shelf computing, etc., so that we can localize these solutions? So here's just that example again, the same platform, add a hitch at the back with a dolly wheel system, and then all of a sudden you have a mechanism by which you can both detect individual plants. You can start to do things such as crop yield estimation, again, using just this phone that's controlling the platform and the AI system as well. You'll see here just some plots here just showing you different yield estimations down to the individual plant level. And then we can add these tools. So here we have a sprayer system, which is not just spraying, but it's actually talking to the phone and doing precision spraying, so detecting where the plant is and just microdosing, just spraying on that each individual plant as it's coming through, whether it's the weed detection and weed spraying, and here trying to do some sort of level of precision planting as well. So again, all off-the-shelf tools, piecing together, trying to connect it with some open source software and throwing that all together in some form. So what I've shown you now is this platform. But what I also want you to think of when you see something like this is that all it is really just a two-wheel tractor. There's nothing more than a two-wheel tractor that's been automated in some form. So the question now becomes, do we throw these smart tools straight into smallholder farmers, or can we take existing assets that are already there and start to put a lot of this technology on there? And that's where we have a project now that's going to run for the next 5 years, looking at in the Mekong region. There's over 130,000 two-wheel tractors, diesel-powered two-wheel tractors that are sitting in sheds and not doing much. Women don't want to play around with the two-wheel tractors. They're too big, diesel-powered, they vibrate a lot, etc. And the youth find it very, very boring to kind of walk around with two-wheel tractors. So the question now becomes, can we take these existing two-wheel tractors and can we start to add this intelligence slowly, and can we build a platform around that? And this project's now in Cambodia and Vietnam. There's about 30 researchers working on the project. Basically, we're taking existing petrol-powered two-wheel tractors that are found in the sheds. We're working with universities and the governments there to look at how we build a socio-economic platform along with an education platform that tells them how to take these existing two-wheel tractors, electrify them, If you look at the industry that's going on in Southeast Asia, tuk-tuks and scooters are all becoming electrified. There's already an industry there where there are mechanics, auto electricians, battery systems, already that electrification process is happening. So how do we take these two-wheel tractors, take off the petrol engine, replace them with electricity, stops the vibration, makes it a lot smaller, makes it easier for women to use. If you take something like that and then also start to power it with some AI solutions, as I showed you before, with the computing platforms and adding the smart tools, then all of a sudden you have this mechanism by which you can take existing old two-wheel tractors and start turning them into electrified smart tractors. But again, the idea here is not about the technology itself. What we're doing here is building a framework around there where we're trying to make this a lot more sustainable and tap into the local ecosystem. So hopefully that's shown you a little bit about the work that we're doing and where we're going over the next few years, and happy to talk to anyone afterwards about the project. So thank you.
So, Sala, I want to start with you, actually, because you touched on something very interesting that I think it would be nice to elaborate a little bit about. You talked about building this socio-economic platform around the tractors. What does that mean, and what do you envision there as possible?
Great. So what we're doing at the moment now is there's lots of workshops with the local community, working through the universities, mainly with women, and asking questions such as, if you had something like this, what would that look like? How would you use it? And the idea being that you can take these existing platforms and then start to working on it in a certain way that makes it easier for the women to use. So that's one part of the process. The other part of the process is working with the universities there. So we're doing a lot of knowledge sharing, in that process about how you electrify these platforms, how you can use open source AI systems to do things such as crop monitoring, crop health. What does electrification look like? So that's another part. And also then with the local government and with third parties about how you could take the rest of the ecosystem that's working in the space, such as, like I was saying before, the scooter industry, et cetera, and kind of tie all those elements together. So while the project there's one part which is technology, that's only about 15% of the project. The other 85% of the project is how we build that framework around there and co-design the process with the community.
So that's the entire ecosystem of who uses the data, makes it usable, who maintains these things,
Exactly
distributes it, et cetera.
Exactly right. Who are the, what would the eventually what would a business model look like as well? Are they service providers? So that's another mechanism to it all. When all this data is connected, also regionally from farm to farm, can you somehow pull that information together and use it? And then something breaks, something fails. How does that whole service process work?
What I love about this is there is a long and checkered history of putting technology into the hands of farmers and smallholder farmers. And what you're saying is, instead of putting something that is entirely new, that involves building new habits or sort of farmers doing things that they didn't do previously, can we build from the assets that are already there and use them as a platform to construct more things?
That's right. Yeah. So one of the key aspects of the project was, how do you leapfrog? So how do you go from what's currently in that situation and bypass the timeline of going there through slowly and jumping through that? And one of the key things that the funders told us was, we just don't want more assets in the sheds. So the question becomes, okay, so you go from one shed to another, and as we said before, in that Mekong region, there's over 130,000, roughly speaking, two-wheel tractors already existing there. Yeah. There's a large percentage of those that are just sitting there not doing anything. And there's a large cohort, large group of farmers who don't want to use them because they're too cumbersome and too hard. So how do you kind of facilitate that?
And you've got a distribution network there. You've got, if you're using mobile phones, there are people who fix mobile phones, et cetera, et cetera.
Exactly.
Fascinating.
Yeah, exactly.
Gabby, I want to come to you, actually, because there's something that you mentioned in your presentation around the the spatial, geospatial language model, essentially, that you folks developed, right? And what I'm thinking about is, what are the different roles that we can all play in this system where people are developing AI use cases? I think that for a period of time, at least, it was very hot for people to develop their own language models, right? And I think now people have kind of stepped back and said, maybe we don't all need to develop our own language model. There are other things that we could be doing. And so, in this conversation, I've heard a few different things, and I'd love to hear, Gabby, what you think are some of the roles that we need more people playing kind of entrepreneurial, an entrepreneurial role, building things in those spaces. But here's what I've heard so far in the conversation. I've heard data collection important, right? I've heard we need to work on the enabling environment. So who are the different stakeholders, whether it's the intermediary organizations that are helping incubate these solutions or that are providing technical assistance to governments. We have the applications. We've heard a lot about the applications or the use cases here. Some of them are software, some of them are hardware, or a combination. And then, of course, there's the foundational infrastructure, the language models, the AI tools, and perhaps there are other things. And I think maybe there's another piece that is coming out from this conversation as well, which is platforms. So platform is a level above a use case. It is something that you can build other use cases on top of, right? And we can, amongst these 5 areas, we can all come in and play some kind of role. But are there additional ones? And is there an area where you feel there's a need for there's a gap, right? We need more people coming in to play a certain role in this space.
All right, to start, I don't work on language models, and so we work on geospatial foundation models, but these foundation models ingest satellite data and output maps, basically, with some nuance there. So that's my context, not language models. I will say that I think one of the difference between the language models and these geospatial foundation models is that often us folks who are developing these geospatial models come from a background of map making. So I got into this because I was trying to make good agricultural maps and having trouble doing that. And that means that unlike the language models, I suspect, we're very interested in your feedback as the developers of these models. And so we work with partners like across the ag space, but also other remote sensing applications, to try and understand how their use cases affect the development and pre-training of our models. And so I think that that's one of the big differences. Now, to concretely answer your question, which is like, what are all of the roles that are necessary to play this? Obviously, I don't think that I'm necessarily the best qualified person to answer this, being a developer of models myself. But we need feedback from tons and tons of people. And especially so for instance, in the development and deployment with World Serial, we worked alongside World Serial in the development and training of the model, but then also, for those of you who might know, World Serial is a massive team, and we solicited feedback from everyone working on that, and World Serial itself is doing outreach to folks like FuseNet or GeoGlam to understand how they're using these maps. So, yeah, basically everyone has a seat at the table, and yeah, I think there's room for everyone.
That's really interesting. So if we're kind of thinking about a process of rapid development and testing, then you need an easy way to access people who can give you that feedback back, right? Who are the users potentially.
Yeah, and that's exactly what happens. So if anyone of you are interested or have used models like Presto or Galileo, which are the models I discussed earlier that are all open source and available, the people who use them message me typically, or other people who are developing these models to get improvements to see how they can use these. So yeah, absolutely.
Ricardo, I think that we often desire, and we know that we're supposed to go and take our work out and test it frequently and iterate, but there are many things that kind of hold us back from doing this, right? The culture of iteration is not present in many institutions, and I'm curious if you have thoughts on how to better enable that, right? How do we make it easier for people how do we make it more automatic for people to go out and build and test really quickly?
Well, I think, it's a difficult one. So it depends. Like if you are, for example, asking about exactly our work, or like maybe something that Gabi was mentioning, I think its use case is a bit simpler, but in principle, like people providing ground truth data so that they are better able to train models on labels. Labels are these basically ground truth data. That's a way in which easily people feedback can be incorporated into the development of products. Our case is a little bit different, and here I'm just talking about the safeguards part, because obviously we are serving a specific functions within FAO.
Yeah.
So in our case, let's say, users are eventually project formulators, let's say. So in that case, feedbacks would come from whoever is developing a project.
Yeah.
And let's say, the expert guidance on what goes into AI, that's is not the project formulators. This would be technical expert on, let's say, forestry or water resources. So that's a different pool of people. So
Right.
users as project formulators.
But you have ready access to your users, which is great. It sounds like.
Well, yeah, yes. So we are right now. We are still in development. So we're not in. We didn't deploy. So we're not, let's say, at the moment gathering direct feedback from users because we're still developing.
Okay.
And I'm connecting to what Brenda was saying before of this incredible speed of development of AI. Is one of the reasons we're actually still on development. When we started development, what I showed you, we started 1.5 years ago, and there was the first release of the API there was a multimodal model, so a model that would be able to understand images.
Right.
And 1.5 years later, we are talking about agentic systems that can do much more.
Right.
And so this is a constant chase in people that are developing solutions to be able to kind of always be there on the latest technological advancement.
Yeah.
I hope I don't think we're going to keep growing exponentially, but that's one of the reasons also it was hard for us to now gather feedback from users because we're still developing and chasing technological advances.
Yeah.
It's a bit
Well, yeah,
challenge.
and we have Gab in 10 days doing applications, and I think some of us are struggling to like schedule meetings in 10 days. Brenda, I want to come to you. I have to admit that I think you're asking all the right questions, but I have to admit that those questions can be very overwhelming. It's a lot. And some of these questions, I'm not even sure we have answers to, right? How do we share back the benefits of collecting data from farmers to those farmers? Do we have institutions and mechanisms available for that? And so I wonder, you know, for those of us who are in some way in a position to work with governments or with organizations that are kind of helping shape what the enabling environment looks like in a country, is there something that we can focus on, like the development of a strategy or roadmap for a particular country? What is the sort of center point that allows us to maybe start to answer many of these questions so that we don't feel a sense of overwhelm trying to deal with all of the different challenges of AI at the same time?
Yeah, no, thanks. If you think about it, if we are overwhelmed, think about governments themselves. Governments are overwhelmed in terms of what they need to do. How do they respond to the questions, the same questions that I was asking and more? I think what we have been doing so far was to, of course, yes, the roadmaps and the frameworks can support, but still these are documents that are sitting, we write and they're sitting there, somebody has to refer to them. But it's the conversations that are happening, the real conversations on the table. So we've done a couple of what we're calling policy dialogues, but around AI, but bringing in all the partners within that space and asking each other these questions. So we did a policy dialogue in Nigeria, where we had farmers, we had private sector, we had also the researchers and donors. So we're all asking, and the first ones to speak were the farmers. The first one we were asking, what do you want? And those were simple. We just want to produce, we want to know where to get the inputs, we want to make sure that we have the right information so that we can be able to sell our markets at a good profit. For them, it's like, our needs are simple, right? Why are you complicating those things? Right. But when you look deeper, when we're looking at now the AI, the application of AI itself, for governments, they need to know what are the ethics around AI? What is the ethical use of AI? How do we plug into our NAS and systems, our legacy systems? Because now you're looking at systems that are developed in isolation. So how do they start making them to speak to one another? How do we start pulling data from all the systems that we can build a model? The question of, can we afford an LLM? Right. So all these questions, that's what they're being asked. But where we are starting to plug in is now, like you say, to support them to build their own strategies, roadmaps that are long-term, that they're now saying that, yes, as much as AI is advancing, but at least let's start from somewhere. We have an example where in Tanzania, where the president woke up and said, I want all systems in government to be interoperable. So everyone was running, how do we start making systems interoperable? But it's now going back to the drawing board and say, where do we start from? Start looking at our business processes, mapping our strategy so that it's actually looking at where is the waste within our systems? Where is the data coming from? So within in-country, all these conversations need to start happening. But it's not just a conversation of government. They need to bring in the farmer so that you're actually addressing the needs of the actual user of the systems,
Yeah.
but also bringing in the private sector. Because most of the times we are speaking to ourselves, and the people that are actually supposed to make the systems work in the ecosystem are not on the table.
Yeah.
So all these conversations need to bring in government and the private sector as well.
And now's the time for it, right?
Yes.
Mike, 30 seconds. There's this roadmap. How can we take advantage of it? How can we use it? How do we? How does it support the people here who might be developing AI use cases?
Yes. I think I was very pleased to see that we see all of these matching the missions that we talked about, right? Optimizing farming through analytics, upgrading institutional capacity. So I think here the main thing is to think about the use cases or solutions you might have and how they map onto those missions and what you can do to, I would say, accelerate the coordination around these use cases and solutions. I believe what you're saying is that we should maybe match the innovators, policymakers, to have more coordination between them. This is the purpose of this roadmaps and the tools that are developed. So maybe you can, we can talk about your projects and we can see how can we match you with the right stakeholders in order to accelerate them.
Excellent. And so to close off today's session, I'm very happy to invite Piedad Martin, who's the Deputy Director for the FAO Office of Climate Change, Biodiversity and Environment. Piedad.
Hello, good morning, everyone. And I'm very happy to be here, and I was listening very carefully. It's a very interesting conversation, and I was asked to close it, so I have some formal speaking points and some ideas also from what I've been hearing. So I think it's very clear that artificial intelligence is shaping the way we are working on food systems and shaping also the way FAO is working. And I'm very looking forward to the FAO Digital Agriculture and AI Innovation Roadmap. And I'm very happy to see that we, under the leadership of the Digital Agriculture team, we have a pathway to follow. And I wanted to share a little bit more on the 4 steps that we are going to advance. So first, we are going to pilot the first cohort of AI use cases applied to digital agri-food systems transformation. And I think it's very interesting, it was mentioned by South Africa in the beginning, that it's important to have both innovation and cooperation. And the innovation, I think we don't need to think also of the tools, but also on the processes. So exactly this first pilot is about the process, how we can bring the collaborative spirit of everyone to how we innovate. Because sometimes the innovation is in the traditional knowledge, it's in our ancestors. It could be, but we have also to bring them in. The second step is to develop a partners and community ecosystem, because we have seen that rarely this information is available. So as it was mentioned by some of you, we are not seeing that people are accessing the tools that can catalyze ideas. So it's important to bring this ecosystem. We are going to launch our first AI services with the STI portal that was mentioned, and we will offer new services. And something that is very important for us is to ensure that specialized AI systems and services remain public goods. So why FAO or the UN is stepping in? Because we see that the breach is widening very fast. And it's not only between rural communities in Africa or Latin America and us. It's also between us and the companies that are already using AI in a very intense way. So I'm part of the breach. I'm trying to use AI, but I'm very mindful that possibly I'm not using until its potential. No? And then the fourth step is to build and operationalize the AI governance toolkit, with, again, ensuring that when the rest of the teams of FAO, we have country offices, regional offices, technical divisions, engage in AI, the products are responsible, transparent, and compliant with the criteria that we have agreed all together. And I wanted to share a couple of warnings and a couple of calls. One is that I think in the World Food Forum is being very clear. There are many voices saying, we want to co-design, yes, and it's important. It's a word that is very fancy now, but the co-design needs to happen from the beginning. What I mean with from the beginning, from when we are framing the problem. And I tell you this, for example, when I was in Nicaragua many years ago, and I reached this community, and they told me, our problem is that we don't have a hospital. And I said, no, this is not your problem. So we need to frame the problems in a way that it works for the communities, that it works for us, and that can give us to identify the solutions. What is your problem? That when I'm sick, I don't have a doctor, I don't have access. Okay, so then maybe the options are wider, no? And maybe AI can also help us to identify those options. But I think it has to be really from the very beginning, how we frame the problems. Then the second warning is on to being aware of the risk and the discrimination that we can create. And I'm very happy to see that our safeguards team is embracing AI, because in our case is through the application of very rigid and standards on safeguards that we are trying to do not harm in all the dimensions that it's embracing: social, environmental, economic. So it's a very systematic way. So if we can insert AI there, I think that we can ensure that it's a structural effort. So I would like to say the call and the warning is, we are very aware of the environmental footprint of this technology. We already have issued, as the UN reports, UNEP has, my former house, has issued some reports on the water consumption, on the energy consumption, and we are seeing really an evolution of this demand. So I think we have to use it in a very responsible way. But at the same time, I think, and this is the call, that we can also model the way. So in my case, we have a team of more than 200 people, and I'm telling them, use AI, familiarize yourself with it. Don't think that because your work is, I don't know, administrative, you cannot use it. I think we need to, we have a role in democratizing the tools. How? Helping our neighbors, our family members, our workmates to don't fear it, access it, know what it is. If you can apply it, fine. If it's not useful, well, it's also fine. But don't. So we can not have this barrier and this bridge. So I think we have to encourage this familiarization, but at the same time, also be aware that there is a footprint, that there are some risks, and we cannot abuse it. So I'm very happy to have this conversation. I'm very happy to see that the UN, not only at the General Assembly level, but also at the very field level, is taking this seriously and trying to bridge these gaps, particularly in our case, between farmers, women, youth, and the use of this technology. And I thank you all for the conversation we just had, and I'm looking forward to continuing it. Thank you.
Piedad, thank you so much for the comments. A big thank you to our panelists as well and presenters, including online. And I want to encourage you folks all to say hi to each other, because everyone here is working on something related to AI or interested in working on something related to AI and agri-food systems. So you've got a network here already. Thank you and enjoy the rest of the day.